All right. So number one was L'Hopital's rule. Was there any issues with number one? Okay. Two, L'Hopital's again. I bet there was issues with this. No? Okay. Do you need me to go over it? Okay. So one and two are both L'Hopital's. Three, what you had to do to find the removable discontinuity is factor the top, factor the bottom. Okay. Whichever cancels, that's where the hole is in the graph. So the x minus, or was it x plus 2's on the top and bottom canceled, so you know x equals 2. Or x equals negative 2. Yeah, x equals negative 2. Then you plug the negative 2 back in the original problem, or the other points. You have to plug them in the other 2 points to figure out it's negative 1, right? Because the answer was negative 2, negative 1, right? Okay. Number 4. Gotcha. I bet a lot of you, right? Okay. Now, you looked at it and said, oh, number 1, and you put in the 3. Oh, they aren't equal, so that doesn't work. Then you jumped down to D and said, oh, they are equal, so that must be it. But the problem is, notice the x is less than 3 for the 1, x is greater than 3. It doesn't say it's equal to 3, right? So 3 could be something totally different. If you actually put a 3 into B, you're going to get a 0 in the denominator. That doesn't work. If you put 3 into C, you get 0 over 9 plus 12 plus 3, which is 0. So it works. Okay? A 3 works. It's continuous for that function. It just happens to equal 0, but it's a function that it's not going to have any discontinuities right there at 3. At negative 3 and negative 1, it would be discontinuous because there's asymptotes for that, for C. But at 3, there's not going to be an asymptote. So D was a gotcha type of one. Didn't mean to, but that's just what happens sometimes. Tangent line. Any issues with number 5? Do you want me to do number 5? Okay, number 5, let's do. Okay, so if y equals 3 sine of x squared, it's like this. Okay, so the first derivative of this would be 6 sine of x times the cosine of x, because it's the chain rule. You have to take 2 times the front times what's inside to the first power times the first derivative of the inside. So chain rule. What?
Why don't they write it like that? Because they hate to. Right? Like sine squared of x. That makes it seem like it's something.
Well, sine squared of x is sine of x squared, because that's different than this. Okay? These two are totally different, and that's why they write the squared like this. Okay? Squared inside. Okay, so then we put the pi over 4 in here. So y prime of pi over 4 equals 6 times the sine of pi over 4 is square root of 2 over 2. The cosine of pi over 4 is square root of 2 over 2. Okay, so you get 6 and 2 cancels to be 3. Square root of 2 times square root of 2 is 2. 2 over 2 cancels, so this is just 3. Okay, so that's your slope. X is pi over 4. And if you put it into the original function, the sine of pi over 4 is square root of 2 over 2. So it's 3 times square root of 2 over 2 squared. Well, that would equal 3 times 2 fourths, which is 3 halves. So this is your point. This is your slope. Put it into point slope form. Y minus y1 equals your slope times x minus x1, which is choice D. Okay. Okay. Now 6. There was 2 of these on this one. I was surprised, but they put 2 of them just on this part, exactly like this. So yesterday in class, I said, know that this is a form. What is this saying? It's saying, what is the first derivative of the secant of x at pi over 2? That is what it is asking. What is the secant of x at pi over 2? For what is the first derivative of the secant of x? So f of x would be the secant of x. What is its first derivative? What is the first derivative of a secant? I think it's secant tangent, isn't it? So that's on that memorization sheet, right? So secant is, secant tangent. And so if we put a pi over 2 in here, the secant at pi over 2 is 1 over the cosine of pi over 2, which is 1 over 0. So this would be undefined, which is choice D, which was why the answer is D. Are we good there? Okay. That's why it's undefined. So we'll come to one later that's just like that, but it's maybe a tangent one. So that's what it's asking when you see that format. Okay. So, sorry. Six is just the product rule. So do I need to do 6? It's the first times the first derivative of the second plus the second times the first derivative of the first. Hearing nothing, I'll go on. Number 8 is the chain rule. 4 times that to the third power times the first derivative of the inside, which if you look at that, I would say just looking at it, it's probably D without working it out. Was it D? Yeah. Okay. So, because it's the bottom times the first derivative of the top. Yeah, you could just kind of look through there and say, yep, it's got to be D. Okay. All right, number 9. Let's do this one, because I bet a couple people missed number 9, huh? Find the second derivative of that. So x squared y squared equals 4. Second derivative, well, we need to find the first derivative first. First derivative of this is x squared times 2y dy dx plus y squared times 2x equals 0. Okay, you got to solve for dy dx. So 2x squared y dy dx equals negative 2xy squared. If we move the other part over, divide by 2x squared y. So dy dx equals negative 1y over x, because the 2's cancel, the 1x cancels, 1y cancels. Okay, first derivative. Okay, now we need the second derivative. So the second derivative would be the quotient rule. X times the first derivative of negative 1y, which is negative dy dx, minus negative 1y, or negative y, times the first derivative of x, 1, over x squared. Well, dy dx is this. So you take this and you plug it in for that. So it's equal to x times the negative of negative y over x, which makes it a positive, minus a negative y, which is plus y over x squared. Well, this is all multiplication here, so these cancel. So it's 2y, because it's y plus y, over x squared. Now you plug in 2, 1. You plug in a 1 on the top, a 2 on the bottom. You get 2/4, which is 1/2, which is choice B, which is the answer. Yep.
got 42.
You got.
I got 24.
Where the first derivative, most people can get to the first derivative without a problem, but they forget that where that dy dx is, you got to plug in the first derivative and replace, and then you can get there. Yeah. Okay, we ready? Okay, this next one is not, I do it the long way. There's a shortcut, but I go the long way around because I don't ever remember the shortcut in my mind. So here we go. We want to find y when dy dx equals x plus xy squared and y of 0 equals 1. All right. So we got to use separation of variables. How are we going to separate our variables? So dy dx equals x times 1 plus y squared. So I'm going to divide both sides by 1 plus y squared and multiply both sides by dx. So I get 1 over 1 plus y squared equals x dx. Oh, and this is dy behind there. So we're going to integrate. Now, do we know how to integrate this by using the reverse of the quotient rule? And the answer is no, because we have a y squared there. So we got to think, where have I seen this before? Oh, I remember. That's the arctangent or inverse tangent. So we have the inverse tangent of y equals 1/2 x squared plus c.
So that whole thing just turns into tangent.
Inverse tangent or arctangent, either way, inverse tangent, arctangent is the same thing. But it wants y alone, correct? So how do you get y alone? How do you get rid of inverse tangent? You regular tangent both sides. So you tangent this side and tangent that side. So y equals a tangent of 1/2 x squared plus c. Okay, now we're going to put in a 0 for x and a 1 for y. So 1 equals the tangent of, oh, actually, I should have done that at the previous step, shouldn't I? Yep, I needed to put that in at the previous step because I got to solve for c first. Sorry. Got to figure out what c is. So the inverse tangent of 1 equals 1/2 of 0 plus c. So 1/2 of 0 is 0. So c equals the inverse tangent of 1 is at pi over 4. Because what's the tangent of pi over 4? It's 1. So the inverse tangent of 1 is pi over 4. Okay? And as Carlos deduced, hey, all of them are like that, so c has to be pi over 4. So then you have the inverse tangent of x or y equals 1/2 of x squared plus c plus pi over 4, because c is pi over 4. So you regular tangent both sides. So y equals the tangent of 1/2 x squared plus pi over 4, which is choice C. Nope, choice B. Choice B. Number 11. Again, know your memorization sheet stuff. What's the first derivative of secant? Secant x, tangent x. What's the first derivative of cosecant? Negative cosecant x, cotangent of x. Okay? So that is the first derivative. Oh, yeah. Number 12. Some of you were discussing this one in class yesterday, I remember. Because, like, if you put in a 0, you're going to get the natural log of 0 in the denominator, which doesn't exist. And so, yeah, you're stuck there, right? So, if we can't do that, what do? Well, we take the first derivative of it. Okay? So, the first derivative of that is, in the numerator, we get 1 over x squared plus 2x, 1 over x squared plus 2x, times the first derivative of that, which is 2x plus 2, over 1 over x. Okay? Now, obviously, this is not the answer yet, so we got to simplify this. So on the top here, we got 2 times x plus 1 over x times x plus 2. And then we have all this over 1 over x. So how do I get rid of my 1 over x? Multiply by x in the numerator and up here. So these x's cancel here. And guess what? This x and this x cancel. So I get 2 times x plus 1 over x plus 2. Now if I put in my 0, it's 2 times 1 over 2, which is 1, which is choice C. Number 13. 13, the integral from -1 to 1 of 4 over 1 plus x squared. If you have your calculator, you just put it in. But guess what? This is the non-calculator part. So we can't do the reverse of the quotient rule because there's an x squared down here and no x's up there. So we got to think, where have I seen this before? Ooh, that would be inverse tangent. Or, yeah, inverse tangent. So what I'm going to do is pull the 4 to the outside. 4 times the integral from -1 to 1 of 1 over 1 plus x squared dx. And now this looks like the tangent thing. So it's 4 inverse tangent of x from -1 to 1. So it's 4 inverse tangent of 1 minus inverse tangent of -1. Well, the inverse tangent of 1 is pi over 4. The inverse tangent of -1, where's tangent -1? Well, you go down here, which is negative pi over 4. Minus a negative is plus a positive. So it's 4 times 2 pi over 4. Well, the 4's cancel to get 2 pi, which is choice C again. Inverse tangent is where on your unit circle. Okay. Unit circle. Okay. This is tangent and this is sine. This is tangent and this is sine. This is cosine and this is cosine. That's where you find the inverses at. Okay. So if you're at 1 here, where is the tangent equal to 1? Well, it's where square root of 2 over square root of 2 is, which is at pi over 4. Because the tangent of pi over 4 is square root of 2 over 2 divided by square root of 2 over 2, which is 1. Okay? So where is tangent negative 1 at? Well, tangent's negative over here, but we don't use this quadrant. We use this quadrant down here. Because tangent and sine run from negative pi over 2 up to pi over 2. Cosine runs from 0 to pi. That's something you just have to remember. Okay? So you don't use 3 pi over 2 down here. It goes this way and this way. So it's negative pi over 2 to pi over 2 for tangent and sine, 0 to pi for cosine. So it's knowing your unit circle. All right. Slope fields. Now, what is the slope field for d x squared y squared? Now, this was super easy if you thought of one basic fact. What is a squared times a squared? It's always going to be positive. So your slope, is there any slopes that are always positive or 0? Well, that's choice A, is always positive or 0, okay? But if you didn't get that fact, you start picking out points. I like to pick out point 1, 1. If you put in a 1 and a 1, you get 1, right? So it should have a slope of 1 at the point 1, 1. So I know A works, B works, C works, and D works. They all work. So 1, 1 wasn't that great of a deal. So then we'll try negative 1, negative 1. At negative 1, negative 1, negative 1 squared is 1. Negative 1 squared is 1. 1 times 1 is 1. So at a negative 1, negative 1, we should have a slope of a positive 1, which works for A, does not work for B, or does work for B, does not work for C, and does not work for D. So you know C and D are eliminated with that one. So then we try negative 1, positive 1. At negative 1, positive 1, we're still squared, squared, so it's positive. At negative 1, positive 1 for B, it's negative. So then you're deduced down to choice A. So just start putting in points and figure out which ones you can eliminate, and thus A comes out the winner. Because after you start doing these, you figure out no matter what you do, everything's positive or 0. So that's where you end up at. Average value of a function. This one got me. This was the first one. I think I made first 14. I didn't have a mistake. And then 15 got me because I was struggling with it. Average value of a function is 1 over b minus a, the integral from a to b of f of x dx. Okay, average value of function. So it's 1 over the cube root of pi over 2 minus 0 from 0 to the cube root of pi over 2 of sine of x cubed and then times 3x squared dx. Well, we use u to say u equals x cubed, so du equals 3x squared dx. Hey, I've got that going on. So really, this is the integral from 0 to the cube root of pi over 2 of the sine of u du. Well, what's the sine of u? Negative cosine of u plus c. Okay, but it's not plus c because this is it has choices. It's a defined interval. So you have 1 over the cube root of pi over 2 times negative the cosine of the cube root of pi over 2 cubed, because it's x cubed, minus negative cosine of 0 cubed. All right, so if we cube this, so it's 1 over the cube root of pi over 2. If we cube this, we get negative cosine of pi over 2, which is 0, right? Minus the cosine of 0 is 1, minus a negative 1, so plus 1. So it's 0 plus 1, which is 1, which thus leaves it as that, which is choice A. That's how we got it. That one tripped me up for a while. 16. The fundamental theorem of calculus. And actually, it's the second fundamental theorem of calculus. But all you do is, when you have the derivative of an integral at some place, you just take this and plug it in all three spots. So it's 3x squared plus 4 times 3x squared times the first derivative, so d dx of 3x squared. So it's 9x to the fourth plus 12x squared times the first derivative of that is 6x. And if we distribute, we get 54x to the fifth plus 72x cubed, which is choice D. All right, 17. When you see fractions in integrals, what you got to think is you got to set them up for natural logs. Okay? When I saw this one, I didn't really know how to attack it, so I said, hey, let me revert back to trig and help me out. How can trig help me out? Well, secant is 1 over cosine of x. Cosecant is 1 over sine of x. So that's a complex fraction, so if you multiply by the denominator of the denominator, so all of a sudden you have the integral of sine of x over cosine of x, or the integral of tangent of x. Now, on that memorization sheet, they do have the integral of tangent of x as the natural log of something, but I can never remember that. So I don't change it into tangent of x. I leave it like this and solve it. Now, when you have a fraction, you have to do the first derivative of u has to be your du. So I'm going to put 1 over cosine of x, sine of x dx, because u equals a cosine of x, so du would be negative sine of x dx. So this is u, this is du. I need a negative and a negative 1 out front. Then I got 1 over u du. Okay, so how do we integrate a fraction like that? Well, it's the natural log. So it's the natural negative 1 times the natural log of cosine of x plus c, which is that an answer? Negative 1 cos, that is choice A, isn't it? There's our answer. Now, on your memorization sheet, if you look at the integral of the tangent of x, it is negative natural log cosine of x plus c. Okay? So if you knew that you could stop right there and know that that's tangent and go straight from there. But if you don't know that, that's how you get it. All right. Average value of a function. Average value is 1 over 5 minus 1, the integral from 1 to 5 of x minus 1 squared dx. All right. So if u is x minus 1, du is 1 dx. So you don't have to do anything there. So then integrate. So you get 1/4. And then it's x minus 1 to the third power. And what do you do when you raise it to the third power? Divided by 3 or put a 1/3 in front. Plus c. Not plus c, because it's a defined integral, so it's 1 to 5. Okay? So you get 1/12 of 5 minus 1 cubed minus 1 minus 1 cubed, which is 0, which you don't even worry about. So it's 1/12 of 4 cubed, which is 64/12, which if you divide them both by 4 is 16/3, which is the answer. The next one, really, I did not like the next one. The next one is the only one. Well, did I get this wrong or not? I think I got this one wrong. They weren't nice on this one. I'll just tell you they weren't nice on this one. Okay. You have a line x equals 10. You have a function y equals x minus 5, y equals x minus 5 to the third power. Now, what's y equals x cubed look like? Looks like that, right? X minus 5 moves it 5 to the right. So at 5, you got it coming like this, and it's going to cross somewhere in there. Okay? Now, you're revolving around the line x equals 2. So it is basically the washer method. This part right here is where it's bounded. Bounded by the x-axis, this curve, and 10, and you're going to wrap it around there, so it's going to make a washer. So it's pi and the integral, and since it's around vertical lines, you go from 0 up to where this intersects. So we don't know where that is for right now, but we'll get to it. Of the big radius, which is how far is it from 2 to 10? 8 squared minus the little radius squared, which is 2 minus x minus 5 cubed squared. Okay? All right. So, whoa. Revolved around the line, x equals 2. And so, nope. We're going around a vertical line, so we got to change our x's into y's. See, what this problem is something we didn't study because they've taken it, basically they've taken the shell method off the test. So we no longer study the shell method. This is the shell method. This is from an older test. And we don't have to do this anymore. Let's just skip it. Let's just skip it because I think I'll just totally confuse you guys if we keep doing it. If you want to know how to do it, I can maybe come back sometime later and show you how that works, but let's not even go there. Number 20. Did anybody miss number 20? Okay. So number 20 is the integral of 3x squared times x cubed minus 3 to the 7th power dx. So u equals x cubed minus 3, so du is 3x squared dx. So it's the integral of u to the 7th du, which is 1/8 u to the 8th plus c, which is choice B, right? 1/8 u to the 8th. Okay. So A bowl of yeast initially contains 100 cells of yeast. So at 0 times 0, it's 100. After 1 hour, so at time 1, it has 250. Okay? Find the equation for the yeast. So this is basically y equals CE to the KT, right? You want to stop? So we put the 100 in here. So y equals 100. And then e to the KT. So then 250 equals 100 e to the k. So if you solve, 2.5 equals e to the k, ln both sides. So k equals ln of 2.5. So y equals 100 e to the t times ln of 2.5. Which is choice B, I think. Okay? So, there we go. We'll go through the rest of these before lunch on Tuesday. We'll talk a little bit more stuff about stuff.
Wait, Tuesday, what are we doing before lunch?
Before lunch, we're finishing this. We're doing a memorization quiz, and then, yeah.
Okay, so the car